So, it's time for the first session when you can actually see the desktop of a screen or something, not just PowerPoints. Yay! So, this session is going to be obviously about security in web apps. There's going to be a lot of web apps over the day, like Emil mentioned, but this is going to be more of an overall discussion with how some of the most common vulnerabilities, what they look like, and we're going to go down to some advanced example from the real world. So you can see the difference between the thing that you can find in the vulnerability scanner and the stuff that would actually require a real attacker or a real hardcore penetration tester, someone that can actually understand code and find vulnerabilities. So it's going to be the whole spectrum of that. And it's kind of funny, Fabio and I was going to run it together because he's an experienced penetration tester and web hacker, but I'm the experienced speaker. But he had a speaking engagement like 1 month ago. That was his first ever, and he did so damn good. He doesn't need me for this. So I'm going to be the sidekick, and this is going to be the main guy. So our Italian friend, Fabio Viggiani, take it away.
Yeah. Thanks, Marcus. Okay, my name is Fabio Viggiani. I work as a penetration tester at TrueSec. As Marco mentioned, I focus mostly on web applications, even though I do some other kinds of assessments as well, infrastructure-based. And yeah, but today we're going to talk about web applications. The reason we're going to talk about that is that web apps are the biggest exposures out there today. When someone gets hacked, very, very often it all started thanks to an exposed vulnerable web application. And then the attacker somehow managed to get into the environment and step further. So we find this a lot in our daily jobs and penetration tests. So when you are attacking an organization and you realize that they're exposing a lot of web apps, you have this nice feeling and become very happy.
And as you can see, the hackers are using Macs, yes you know.
Yeah, so be flexible.
And they always use a mask.
Yeah, of course. Yeah. You need that.
Yeah, makes sense.
So we're going to cover a couple of basic things, SQL injection and cross-site scripting. Most of you are web developers, as I saw before, and if you're here, you're definitely interested in security, so I know that you know about these things already. But that's exactly my point, actually. These things have been around for decades. There are well-known countermeasures, there are accepted solutions to these problems. So why do we still find them every day? That is the question we're trying to answer. This thing shouldn't be there anymore. Everyone interested in security knows about them. So we're going to first try to understand how it works. I'm going to go very quick through that part. And then we're going to try to understand how it is possible to still find them today. I'm going to do a few demos. And I'm going to use a demo environment. I'm just going to show it to you now. You don't need to get all the details. I don't know if it's very readable. Probably not, but I can tell you, I'm going to use a couple of VMs as attacker machines. I'm going to target an organization that exposes a web application. That's the yellow public web server there that is using a database. But the organization also has an internal segment, an internal network, composed of a domain controller and internal web server with some internal users. There is an internal database used by the server, and there is some kind of synchronization that is going on between the two databases. But everything, or the only thing that is exposed to the internet is the external web application. So have this in mind. We're going to get back to that later. So let's start with some hacking. We're going to, yeah. You know about SQL injection, so that's already funny for you. Anyway, we're going to start with some basic stuff. We warm up a bit. So let's fire up the attacker machine. which is my demo attacker. Right. This is the web application that is exposed on the external web server. Let's take cross-site scripting first. Cross-site scripting is about injecting a script or arbitrary HTML content into a web page. We're going to see why that's interesting for attackers very soon. But let's first try to understand how that works and how that's possible. So let's take this page. It's the home page. And let's assume that it takes a parameter. That's not very readable, so maybe I'm going to use something like this. So let's say I can browse to that page, and I can provide a parameter with a name, say Fabio, and I try to send this to the application. And I see that that value that I submitted was somehow treated by the application and used to construct a response that is returned back to me and interpreted by my browser locally on my machine. So if I see something like this as an attacker, what I want to do is try to figure out if I can inject something there. Instead of just sending normal text, I can try to send some HTML tags and hope that my browser will interpret those as valid HTML tags. So for example, if I send something like this, oops, slash here, I'm going to try to insert a new line. That's a new line in HTML syntax. I'm sure you know about this. So let's send this, and in this case, the browser actually interprets that as a new line. So I'm positive now that I have an injection. I can inject arbitrary HTML tag, or at least a new line tag here. But what I really want to do is to inject scripts. So I want to inject something like this. Now, as a proof of concept, I'm just going to execute a script that displays a pop-up message. Alert, and it's going to display a 1 or something.
Very creative, very unusual.
I know. We'll get to the fun parts. Don't worry. We're almost there. Now, I inject the script, and my browser interprets that as an actual script, and it executes the content. So if I'm attacking this, I see this, now I'm happy. Because I can do many evil things now. I can show you a tool, a very neat tool to exploit this situation. I'm going to use another machine for this. And I'm going to fire up something called a XSS exploit framework.
And of course, it's for free, right?
Yeah, this is a free
open source.
Is it open source? Yeah, it's probably open source. It's developed by OWASP.
That's like open web application security.
Yeah. OK, this is a server that is listening for incoming connections. And the connections are in a form of a browser requesting an external JavaScript that is served by the server. So I'm going to show you how it works. It's actually easier to show you than talk about it. I'm going to configure my server to listen on this IP address and that port. I'm going to start it. And as an attacker now, OK, well, now this is my attacker machine where I run the framework. Now I'm just going to use a different browser. This is going to be my victim now. But as an attacker, I want the victim to browse to something like this. I'm doing exactly as before. I'm injecting a script, but this time I'm referencing to an external script which is hosted on my attacker framework.
And it's kind of funny because, of course, you can send a link in an email. But looking at the NSA attack I mentioned earlier, this is exactly what they do, but they have routers and they have network points all over the internet. So if you pass through their way, and they know who you are and what browser you're using, that they can inject this and compromise your computer on the fly.
And if it's a single individual attacking you, it doesn't necessarily need to look like this. It doesn't have to be a URL. This looks pretty weird. I would never click that. Probably you wouldn't either. But there are many ways to make someone visit a location that they didn't intend it to, or at least that they don't see.
Or they can buy a banner on a normal website and put the JavaScript in there.
What about short URLs, for example? Or embedded frames in pages that you visit. But anyways, let's not go there. So I'm the victim, I'm visiting this page, now injecting this script. So I didn't insert any visible content, so I don't see any difference really. But what happened is, by referencing to that script now, I'm hooked to the attacker framework. So if I go back to the attacker now, I can now control that browser within the context of that web application. So I can, for example, send a message, which is kind of lame, but you have been hacked. This is quite visible, but you can do this, for example. And on the victim side, this pops up. So I am executing stuff on the victim's browser that I decide from my framework, just because the browser referenced to a JavaScript file that I host. It's kind of interesting, isn't it? How many times do you reference to external scripts? I can do more interesting things than that.
Just curious, are you connected to the internet?
No.
Yeah, I just realized that maybe you want to be connected to the internet for this, or no?
No, I don't.
Okay, just wanted to make sure. When I do this very demo, I use Facebook as an example. That's on the real internet, so sorry.
No, okay, you talk about efficient. No, and I'm just going to mention it, actually, not going to show it. But yeah, good
Bad
point.
for them, it's a cool demo.
Yeah. Too bad, you shouldn't have mentioned that. Now you make me look like they're missing something.
Or you can connect to my virtual hotspot and show it later.
It's okay, we'll see if we have time at the end. Anyway, you can launch phishing attacks, for example. This will download dynamically a page, for example, Facebook, and it will pop it up to my victim browser and trick me to write my username and password, and then it will just collect it from my framework. I can launch a keylogger directly, and then just log every key that is typed, well, within the context of the browser. I can try to exploit browser vulnerabilities to get permanent control, permanent access to the machine. I can get the user to download files. I can use JavaScript to run internal network scans with different techniques. So I can do a lot of interesting things just because I made a victim injecting or just inserting a script in a page they visited, and I control that script.
Yeah, I think this puts a new perspective to cross-site scripting, doesn't it? I mean, somebody can actually own your browser and do a lot of things that you weren't thinking of. Because many times when we do penetration tests, we find a cross-site and they say, well, it's just a cross-site. It will not execute on the server, it will execute on the browser. Yeah, but those are your customers. And they will be owned because of you. So it just puts things in perspective.
Think about internal clients as well, sitting on the internal network. If I launch a cross-site scripting attack against them, then I can use JavaScript on their browser to access internal resources in the internal network. Anyway, this was cross-site scripting, and one way to exploit it, but you know the concept behind it. So let's take this aside for a moment and switch to SQL injection. On this side, I have a page that you can use to fetch news from a database, and you can provide a filter parameter that will filter the result set returned from the database. So if I submit something, this will filter the results. So I know most of you know about SQL injection, so I'm going to go very fast. SQL injection is about injecting or modifying a SQL query that is executed by the web application to retrieve or somehow interact with a backend database. If user input is used to dynamically construct a query that is executed on the database, then we might have an injection if the user input is not handle properly, if special characters in particular are not handled correctly and taken care of. For example, if I insert a single quote in itself has a special meaning in the SQL syntax. That means that I'm terminating the string that I'm in. So if that's not handled properly by the application, I'm actually changing the syntax itself of the query executed by the web application. So if I try this in my demo application, I see that the application returns an error. So I know that I'm somehow affecting the syntax of the query. So this might be vulnerable. I'm not going to go through it manually. I'm going to show you a tool that does this, called SQL Map. Quite common tool, free to use. You can simply point it to the location, the URL, and you can tell the tool what parameters you want it to test for SQL injection. And you can specify other parameters. It doesn't really matter now. So let's say that this application is using a database that contains a user table containing username and password. So for example, I can inject something like this. This will select username and password from the user table and append it to the original query. So if I send this in my filter parameter, the application actually returns me the username and passwords. If I try to launch my automated tool, it will be much faster than doing it manually. If I did it manually, I had to start enumerating the tables and the column names and number of columns and all that stuff, which might be tricky sometimes. So this is just faster and easier. There are some time-based detection mechanisms, so that's why it might take a few seconds. But yeah, it will tell me that the filter parameter is vulnerable. So let's proceed. In this case, I asked the tool to retrieve the user table. Let's do this. Zoom out. And it just went and retrieved that table for me. So obviously, the application did not have any protection against SQL injection in this case. So this was just to show you the problems, but that's not really the focus of this session. The thing is that we should not have this anymore. As I mentioned at the beginning, these are well-known things. We should be able to fix this. We can go online, download some filters, again, cross-scripting. We can read about SQL injection and figure out that there is something called prepare statements, which is the accepted solution for preventing SQL injection. So let's do it. Let's try to fix this. I have the fixes in place already. We just need to use them. So I'm going to log into the web server where the application is running. This is the code behind the application. So the first thing I did was to Google for XSS filter. I took the first result. I adapted it a bit to my C# application. And then I just implemented it. And the filter looks something like this. Let me make this smaller, more readable. So there is a list of patterns that contains all the things that I don't want the user to be able to include in the input. So things like quotes, double quotes, new line characters, script tags, style tags, source tags, blah, 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 and a bunch of JavaScript event handlers. So these are all things that I want to filter out from my input. So what the filter function does is to replace null characters, and it's going to take each one of those patterns and go through the input and try to match it, and if it finds it, is going to replace it with an empty string, and it's going to continue doing that until it doesn't find that pattern anymore. So let's use this. I just need to call it when I receive my input. About SQL injection, I mentioned prepared statements. What prepared statements are is conceptually quite simple. What they do is telling the database engine that whatever I specify to be data can only be interpreted as data. So it cannot affect the SQL syntax itself. So if what they found to be data contains special characters, for example, a single quote, the database engine will only interpret that as a single quote literally. So if I filter for a news containing a single quote, I will actually look for a news containing literally a single quote. And that will take away the special meaning that allows me to affect the query itself. It's really easy to implement. I'm not going to show you the details. You can just trust me on the fact that I implemented it correctly. It's fairly straightforward. I have it ready. I'm just going to comment this function out and use the fixed version of it. I'm going to republish my application. And this should be fixed now. But this looks more like a real case scenario. So the first example I show you, that doesn't usually happen in real life. That was really too easy, not even fun. So what I want to try to do now is to put myself again in the position of the attacker and try to hack again this application, but now the fixed version of it. And let's see what happens. So let's go back to my attacker machine, which is here. So let's take cross-site scripting again. I want to verify that what I used before doesn't work anymore, first of all. So I want to verify that I can't execute this script anymore. So let's run this. And I can see now that what's being returned by the application has been modified. So if I'm attacking this and I observe this kind of behavior, I know that there is some kind of filtering going on in the application. So I don't stop there. I try to figure out, I try to guess how that filter was implemented and if there is any way to bypass it. So for example, in this case, I know that they filter out the script tags. So my first thought is, what if I insert something like this? You see the difference? I have a capital R and a capital C in the script tags. So my thought is, what if the patterns are matched in a case-sensitive way only? So it's actually going to look for script tags lowercase. In that case, this would be enough to bypass the filter. So that's the first thing I try. I send this, but it doesn't work. Too bad. Not that easy. But I can go further. My next thought is, what if I send something like this? What if I encapsulate a script tag within a script tag? Because I know that that's going to be replaced with an empty string by the application. I observe that behavior. So what happens is that when this is going to be replaced, then I end up with a script tag again. Let's try to send this. Maybe select it first. Copy and paste. But no, that didn't work either. So obviously, the matching mechanism is being done recursively in a way. We kind of saw it before very quickly. There is a while loop, so that keeps matching that pattern until it doesn't find it anymore. So this is not going to work. But if I keep assuming things like this, then I can say, what if that pattern is matched recursively, but only for that pattern before moving on to the next pattern? What I mean is, what if I send something like this? I am encapsulating a onload JavaScript handler within my script tag. Maybe because I did some more tests, and I know that the onload JavaScript handler is also replaced with an empty string. The difference is that when my filter looks for script tags, recursively for script tag, it doesn't find it here. It moves on to the next pattern. And it takes, at some point, it will take the onload pattern, will try to match it, it's going to find it, it's going to replace it with an empty string, so I end up with my script again. But at that point, the script matching was already passed in the list, so it's not going to go through it again.
Some people are smiling because they kind of get it now.
All right, let's go faster here then. I tried this, and this worked. So I was obviously able to bypass the filter.
This is the typical way a pen tester will think. They will just try and make assumptions in how the filter would be developed. And the more you know about coding and what could potentially be used, and the more experience you have, the bigger chance you have to circumvent a weak filter.
So let's go on to something more interesting. Let's switch to SQL injection now. Because I fixed that, right? I guess you're guessing what's going to happen, but I'm using prepared statements here. Now, prepared statements are really the accepted solutions to solve this. So I really shouldn't be able to inject there anymore. So let me fire up my tool again. I'm just going to flush the cache and run it again. If I'm able to inject here, then I've done something really wrong with implementation. But that's not the case. So this is not vulnerable.
It's kind of funny. It's a warning. It's something bad that didn't find an injection.
Yeah, this is the attacker's perspective. So yeah. Red is not hackable. All right, so let's take a step back and try to look at the system again. So from the internet, I see the external web application. I can't inject in that database because I'm using prepared statements. I can't inject in the internal database. Definitely not. I can't even reach it. It's internal. But there is some kind of synchronization going on between the two databases. So what if my news search is being stored somehow in the database for search history reasons or something like that? Now, that's using prepared statements, right? We did that together. So what happens when you use prepared statements is that your special characters, say a single quote, is going to be escaped, but it's still going to be stored in the database. So at the moment of the execution, it will be escaped. But the result, what is actually stored in the database, is still the original value that you submitted as a user. Right? So if there is any other component in your system reusing that data, the same precautions have to be taken again. In this case, the database synchronization job is something completely external to the first application. So from the perspective of that external web application, all database access is covered by prepared statements, which is fine. But what if we assume that that data is taken, again, by that component and used to construct insecurely, once again, a query that is executed in the internal database? Then we could end up with an injection as well. So let's say you have a little knowledge about the internal system that you can get just with some time, really. So I'm going to show you something that you could actually inject here if this works. This, for example. So if this is part of my original query that is executed by the web application in the external database, and that is then taken by the synchronization job and used to construct something executed in the internal database, what I could try to do, if I have a lot of imagination, is to try to, for example, end the statement where I'm in and start a new one and say, OK, can you please update the user table for the username Bob and set the description as a string, the password of the internal admin is, plus the result of an additional select statement, which will take the password from the user table for the admin internal. I'm going to execute this. I'm going to first log in as Bob. I have access to that account. And I can check my profile and read my description. A funny guy. So I want to go back to my news filter now and paste that injection and run it. Now, if that works, I hope that my description has changed now. If I go back to my profile, I can see that that actually worked. So let's see what happens, really. That might be a little unclear. So what happens is, I send my injection to the external web application. I use prepare statements, so my input is going to be escaped, and it's going to be stored in the external database. Now, when the synchronization component takes that input, obviously it uses that insecurely, and executes a query in the internal database, and that's where the injection takes place. Obviously, there is also some kind of synchronization in the other way around, and that's why I'm able to see the updated description from the external side. Because if I update something in the external database, in the internal database, it's going to be reflected on the external. And that was the first reason why we had the synchronization job, to keep data synchronized. But this was not done securely, so we could end up with something that's called second-order SQL injection, when you first store your injection and then some other component reuses that escaped input to execute additional queries.
Would you say this is very unlikely to find in the real world? This is just one of the examples that he found on the job a month ago. That's why he runs this. It could be another demo if it was another job we want to use as example.
Yeah, that's the funny part. I didn't make this up. We actually found this in a real job.
A question. Why not?
Yeah, there are is that what you asked? If there are synchronizations tools that you can use?
Yeah, no, I heard the question, so I can repeat it.
Okay.
Did they use their own synchronization function, or did they use the built-in one? That's a very good question.
Yeah.
Because if you were to use the built-in one, you wouldn't have had this problem. So they used their own.
Yeah.
They created their own script to do it. Because people are people, and people are different, and some people just do it differently.
They might have whatever reason for doing that. I honestly don't know, but it was there.
Yeah, and it's, again, some of the snares are complex. Now, I don't want to brag about Fabio, but another firm did a penetration test on the exact same application, didn't find any vulnerability. Then he did it right after, because this was a project where they did a pre-test and then a later test. One in test and one in production. So it's, if you don't do it right, I mean, it's just about who is looking. If the guy is proficient enough, or maybe lucky enough, making the right assumptions. Another question, why not?
I'm most invested in actually finding out that there was an internal database. There was a synchronization going on.
Well, we had some knowledge about the system in the first place, of course. The thing is, when we do jobs, we have a limited time.
Yeah, we'll repeat the question. The question
Yeah,
was how much time was invested in this, and it's always a question of how much knowledge you have, of course. So if this is something you can buy off shelf, and this is the recommended way of setting it up, then you can just buy it yourself or download the eval, and then you can do it. Sometimes you will not find it because you can't get to the code, or there is no way you can find this out. You don't know they have one, so either you've done this before or you do the assumption. But it will be more tricky. In this case, we actually had some access and some knowledge, but again, if an attacker would invest more time, he could maybe walk in there, make a phone call, send something, browse whatever, where the employees post their problems or anything. He could call someone and say, hey, there is some problem with your internal database. And we don't have an internal database. Ah, sure, okay, good, thanks. I don't know. Just a simplified idea of how you can talk to people and interact in order to find out.
And the example here was tailored to actually retrieve useful data and be displayed by the application. So that's something that really takes a little knowledge or enumeration of whatever resources you have inside. But as an external attacker, you can simply try to inject stuff, and the result will be that something will break in the internal database. Even if you can't exploit it to extract data, it will still cause some problems, and the internal user will start complaining because something is broken.
Yeah, but just to give you some food for thought, I'm not going to say exactly what kind of business this was, because they can feel targeted by us mentioning it, but it was either a government agency, an insurance company, or a bank. Just where you find the stuff.
Okay, we have, I think, a few more minutes. 4.
It's our day, man. You can take 5 extra. You can stop ahead. It's up to you.
No, but I want to show you something. I want to show you how bad this can go if you allow something like this in your system. So I'm going to try to do it quite quickly, but it's... I want you to see this.
Yeah, so this is the focus. While he sets it up, I'm going to explain it. I mean, it's very common, you being the guy writing the application, that you think about maybe securing your application. The worst thing that can ever happen is your application to be compromised. That's not really the case in the real world. Your application could be the gateway into other resources. I mean, in the modern SQL server, for example, you can execute code in many circumstances. If you have the right credentials and you can access the right store procedures, for example. So take it away.
Yeah, before I show you this, I want to summarize something I was about to forget, which is the, the most important part of this session, really, to understand what went wrong from a developer's perspective. And there were obviously a couple of best practices that we didn't follow. For example, we decided to apply a cross-scripting filter, which is really not the recommended solution to prevent cross-scripting. In that case, you should rely on output encoding only, so only instructing the browser when you send the request to not interpret those special characters as HTML. And also whitelisting versus blacklisting. I'm not going to go into details of that. We have later sessions today that are going to focus more on these things. We also only applied localized fixes. So we didn't, what we did is we found the problem, then we went to look for a solution, we applied to the point where we had the problem, and we were done. What we should have done was to think like, okay, we have a problem here, so let's take a step back and look at the whole code structure and see if we can structure it properly to concentrate all our countermeasures in one place so that we don't end up with the same problem anymore when we apply the patch. We want to also apply the fault behaviors. That's also something we're going to talk about more today. So things like whenever you get an input, you do validation. Whenever you send an output, you do encoding. Whenever you talk to the database, you do prepare statements. So if you structure your application to do these things by default, then it's not up to you all the time to remember to use it. So let's get to that final demo and show you what we can do with this. We have a second-order SQL injection, and we can execute things on the internal database from the internet. So as an attacker, what I want to do is try to execute code on some internal machine. In this case, the database and the internal web server are the same VM, but it doesn't really matter. It's an internal machine. So if you have SQL injection, sometimes, depending on your privileges, you can get to code execution on that server. And since I can't control that server directly from the internet because it's internal, what I want to do is try to trigger that server to connect to me out on the internet. And you probably know that if the session is initiated from an internal machine, then it's going to go through the firewall, and then as an attacker, I'm going to be able to control it. So that's the first thing I want to do. I'm going to do this with one single injection. It's a few commands concatenated, but it's one single injection. So first of all, I'm going to start a listener on my attacker machine. This is really just a listener. So listening on that IP address on that port for incoming connection.
Again, this could be in SSL also if you want to do a more covered channel. This is the Metasploit framework. It's
using
something you can download.
4444 as an example, but in real case, I would probably use 80 or 443. Yeah. So I'm listening now on the internet. So I will execute this now. Let me make it a little smaller. It looks like a lot, but it's not that much. I can break it down. So first of all, I am enabling OS command execution on the server where I have the injection, which is in this case the same as the web server, but it doesn't really matter. I am then writing a C# downloader into a file on the server's file system. And I'm storing that into a file called dl.cs. I'm then using...
I can mark it if you point. Or
yeah.
I think it's easier to see with a...
Yeah. So I'm echoing the content of the download, or the C# downloader, into a file on the file system. I'm then using the...
This is the echo.
Yeah. I'm then using the built-in CSC compiler in the .NET framework. That's something that is always there if you have a Windows server. And I'm using that to compile that into an executable, and I'm then using that downloader to download an agent from my machine, which is out on the internet. And I'm then executing that agent. So what the agent does is connect it back to me on my listener on the internet and give me access.
And nowadays this string can actually be shorter because you don't have to do the dl.exe. You can run PowerShell and invoke .NET directly.
Yeah, there are many different ways of doing this. This is just one of them.
I mean, many people think, well, I'm going to find the dl.exe on the file system. It doesn't have to be that. This is more of a good example for your developers because you know about compiling in source code. You can't send a binary in there, you can send text in there, so it compiles.
No, the 4444 is the port where I'm listening for the agent to connect to. So when I execute the agent, it's that process that will connect to port 4444.
This one is pre-compiled as a client thing that will connect to a configured port.
Yeah. I'm hosting that on my personal web server on the internet, and I'm getting the client to execute, to download it and then execute it.
We're going to prove it.
So let's copy this. So I have my listener here waiting. I'm going to go back to my news page, and I'm going to execute this. Go back to my attacker. I have now an incoming connection and a session open coming from that machine, that port, and I can now control it. So I can get a shell. I can try to figure out where I am, host name. I'm now executing on the internal web server. I can check who I am. M system. So obviously that was running a system on that server, which is also not good.
But this is a fair statement. Like many times you're running the DMZ localized SQL server in low privs, but the internal ones are many times running on the system context. Because they're internals, you're not so worried.
So what happened is I open up a channel from the internal machine to me, and now I can control that directly from the internet. But if I really want to take this down, I want to go for the domain controller. So I'm going to use something extremely common in IT environments. That is something we always use to escalate our privileges within the environments as soon as we get a foothold. And I'm talking about system dependencies. There are different kinds of dependencies. I'm going to show you one of them. Let me exit the shell here. Let's list the processes running on this machine. Zoom out a bit. These are all the processes that are running under a certain account on that machine. Now, I have system access to this machine. So what I can do with that access is that I can inject myself into any process running on this machine. If that process happens to be running with the different privilege, then I will get that privilege. I will act in that context. So if there are some domain accounts running things on this machine, then I can inject myself into that process and become that domain user or service or whatever is running. Now, just to make it shorter, now I have something running as demo administrator, which is the domain controller. So what could simply happen here is that the domain admin. What could happen is simply that the domain admin uses his domain credentials to RDP to this machine for remote management or run some kind of remote services using the domain admin account. It doesn't happen directly, or it does, but you might not want to use directly the domain admin account to do like RDP to other servers and things, but it's just a matter of how many steps you take. If you're on one machine, you can get the highest privilege on that machine, and then you can reach wherever that account can access and go further until you conquer everything.
The problem is, on whatever system you log on to, you will expose your keys. So if somebody else owns that machine, he can reuse those keys. And the keys can be in terms of, sometimes it can be clear text passwords, which are actually stored for single sign-on purposes on Windows, in many cases. It could be the password hash representatives of the password. Or it could be just the tokens, the processes, the context you have right now. Or Kerberos tickets for that matter. So many different keys you can steal or reuse.
So with the agent that I executed, I have an interpreter session now that allows me to do these things in a very easy way. So I can simply say migrate and specify the process ID 4772. It will do that for me. It will inject myself into that process. And when this is done, I can get the shell again and ask who I am. And I just became the domain admin. So I stole that token, and I was then able to, of course, access resources on the domain controller. And if that happens, then it's game over. Then I can do whatever I want on that domain. So that was an example of how bad it can go. And these things happen. When we get a foothold, we just start escalating until we get as much as we can, which is often everything there is.
Yeah, and it's kind of funny when you look like in the newspaper and you see there's an APT, an advanced persistent threat. It's like, oh, they used all these advanced tools. You can do a lot of things with these free-to-use tools. This would probably be considered an APT. Yes, you do a web exploitation of a pretty obscure SQL injection. You steal internal credentials, and then eventually you connect to domain controller. You compromise the entire domain. You steal all the users in the entire domain. You can impersonate anyone, steal their IP and data, exfiltrate it out to the internet. And that's what's happening in those scenarios that I and Emil were talking about. When they do an attack, that's what they do nowadays. They're not just going for a web server. But it's going to be damn hard to be the guy who wrote that script or the synchronization thing when this happens. Because they're going to have to find out what happened. So it's going to be very valuable to say, well, I did it right. And I'm not trying to scare you. It's just that we need to fight as developers for for being able or get the time to implement security. I'm a consultant myself. I know when somebody wants you to develop something, it's going to be on time constraints. And how many times do you get like extra time for buddy reviews in regard to security or stuff like that? Like the security development lifecycle things, and implement that fully. It differs. Some people do, or some organizations do, but most of them don't. So this is just a way to inspire you to start thinking these terms and communicate this message into your organizations where you operate.
And hopefully this has triggered in you a different kind of thinking. So when you have to apply a patch next time to a single point, you can try to take a little step back and look at the big picture a little bit more. So that was it from me.
Great. So we're going to first of all say thank you to Fabio. Thank you, Fabio.
Thank you.